Today we're going to talk about acids and bases and conjugate acids and conjugate bases. The term acid, almost think of it as a verb, okay? Bronsted and Lowry said an acid was a proton donator. So that's almost an action, donating the proton. A base is a proton acceptor. And that's the Bronsted-Lowry definition of a base. Okay, the general form that we're going to see for inorganic acids is the H is going to come first, okay, and then you're going to have the rest of the acid, okay, acid. In the most common base we're going to deal with is hydroxide, which is a polyatomic ion that we've already studied, and then there's going to be a cation with that. The general reaction then is we follow the proton. We follow the H+. Remember, H+ is actually a proton, the hydrogen cation. So what happens here is the hydrogen goes on to the hydroxide and that makes water. This is actually water. We write it as H2O, but when we're talking about acids and bases, it helps us to think of it as a hydroxide with an extra proton on it. Okay, so that's where it went. The acid was the one that donated it, the base was the one that accepted it. From the general equation, here's a very common acid, hydrochloric acid. We recognize it again, H in front, HCl, okay? Hydroxide, we said, was the base. What happened over here? We got water and a salt. Acid plus base gives water and a salt. All right, now we have other terms. We said this was the acid because it was the proton donator. This was the base because it was the proton acceptor. On the other side of the equation, the product side, we have terms like the conjugate acid. The conjugate acid is the partner of the base. It's the base after it has accepted the proton. The acid and the base are on the reactant side, the conjugate acid, product side. We also have a term for the chloride. Here, the chloride was part of the acid. After what's left has given away its proton, in this case, this is the conjugate base. Sometimes it almost helps us think of the pairs. Acid donates the proton, conjugate base is what's left after the proton was donated. Base accepts it, now it's a conjugate acid. Here's another example. Sulfuric acid, H2SO4 plus NH3. NH3 is a base. Hydroxide and ammonia are the most common bases we're going to see. What's going on this side? Acid-bases reactions follow the proton. Here, the ammonia accepted a proton. If you're accepting a proton, that means you are the base. H2SO4 lost a proton, became an anion. That means you are the acid. Over on this side of the equation, the base, after it accepted the proton, this is the conjugate acid. See how they form a pair, differing only in a proton. The H2SO4, after it lost a proton, is the conjugate base. Once again, you could think of them as the flip side of a coin, with the proton, without the proton. Okay, those are the terms: acid, base, conjugate base.